Consider the curve 9x squared plus 16y squared is equal to 144 in the xy plane. Is the graph concave up, concave down, or neither at the point -3, 3 times the square root of 7 all divided by 4? Well, in order to determine concavity within any curve or function, we need to find its second derivative. And in order to find the second derivative, we have to also find the first derivative and then take the derivative again. So let's start by finding the derivative of our curve. And we are going to have to use implicit differentiation here because we are differentiating with respect to x, but we also have a y here. So we're going to have to include a dy over dx when we get to that step. So the derivative of 9x squared with respect to x is 18x. And then plus the derivative of 16y squared with respect to x will end up being 32, using the power rule, y times dy over dx. And then we're going to have that equal the derivative of 144, or any constant with respect to any variable, is going to be 0. And next what we need to do is we need to solve this for the first derivative, dy over dx. And to do so, we're going to subtract 18x from both sides. So we'll have 32y times dy over dx is equal to negative 18x. And then when we divide both sides by 32y, we will get that the derivative of y with respect to x is equal to negative 18x divided by 32y, which reduces to negative 9x over 16y. And then again, in order to test for concavity, we need to find our second derivative of this graph. So we know that dy over dx is equal to negative 9x divided by 16y. So to find the second derivative, we're going to have to use the quotient rule here. And the quotient rule is the bottom, 16y, times the derivative of the top, which will be negative 9, minus the top, negative 9x, times the derivative of the bottom, which will be 16 times dy over dx, all over the bottom, 16y squared. And next we're going to simplify this. Now since we have minus a negative here, it's going to become plus a positive. And this first term is going to be negative. So we can switch these around if you'd like. So that's what I'm going to be doing. So 9 times 16 is 144. X times dy over dx minus 16 times negative 9. That gives us the minus sign there. 16 times 9 is 144 again, and we have a y there. All divided by, when we distribute the square through to both terms, we'll have 256 y squared. Notice that we have dy over dx as a term in our numerator. And we already know that dy over dx is equal to negative 9x divided by 16y. So let's take this and substitute it in for dy over dx. And when doing so, we will get 144x times negative 9x divided by 16y minus 144y all over 256 y squared. Now in order to continue simplifying, we can notice that we have some coefficients that are going to cancel each other out. For example, 144 is divisible by 16, so we can cross the 16 out, it becomes a 1, and 144 becomes a 9. And notice that in this new first term, we're going to have a denominator of y. So in order to combine our two terms that are in the numerator of our rational expression here, we're going to have to multiply 144y by y divided by y so that we have that y denominator. So if we now multiply these numbers together to get another reduced or simplified step, we're going to have negative 81 x squared divided by y minus 144 y squared divided by y. And now this whole thing is over 256 y squared. And now we're going to multiply both the numerator and denominator by 1 over 256 y squared. And that will make our function or expression or curve become negative 81 x squared minus 144 y squared, all divided by 256 y to the third. And that happened because these terms canceled out in this bottom denominator. And then when we combine these two together, we have a y, and then times 256 over times y squared gives us 256 y to the third. So this is our second derivative of y with respect to x. And now to determine concavity at our point, negative 3 times the square root of 7 over 4, we're going to substitute these two values into our second derivative and evaluate it. So I'm going to rewrite that point right here. Negative 3 times square root of 7 over 4. So we know what we need to plug in. And when doing so, we're going to have negative 81 times negative 3 squared minus 144 times 3 times the square root of 7 over 4 squared, all over 256 y to the third. Oh, and we can substitute y in there. So let's do that really quick. So we have 256 and then 3 times the square root of 7 over 4 to the third power. And that's going to end up simplifying to negative 3 squared is 9. 9 times 81 is negative 729. And then minus 144 times 9 times 7 divided by 16. And then all over 256. We will have 27 times 7 square root of 7, all divided by 4 to the third, which is 64. And now we can cancel some things out here. 16 goes into 144 9 times, and 64 goes into 256 4 times. So that makes our rational expression reduced to negative 729 minus 567, and I got that by multiplying 9 times 9 times 7. And then in the denominator, we have 4 times 27 times 7 square root of 7, which will give us 756 times the square root of 7. And we can reduce this further by subtracting these two terms in the numerator to give us negative 1,296 divided by 756 times the square root of 7. And that's what the second derivative of y with respect to x of our point, negative 3 3 square root of 7 divided by 4 is equal to. Notice that this number is negative, and when you have negative values from the second derivative, it means that our graph is concave down. Or appears to be in this type of format. So therefore, the correct answer for this question is answer choice B, concave down.